So as we're reviewing for linear programming and matrices for the final, I'm going to tell you a story and I want you to write the equations for this. Let's make X be adult tickets. X is adult. And let's make Y be the student tickets. We have an amazing theater program here. I've had a chance to go and enjoy usually one or two of the shows every year. And this year I enjoyed Spamalot. And as you look out across the crowd, it's mostly adults with some students. And in fact, I'm going to give you an equation for that. We're going to say we had 3 times as many adults as students. Now you can write an equation for that if you know how. 3 times as many adults as students. And it's very easy to get that backwards. So be careful. Next, we're going to have prices here, and the prices for the adults, it's going to be 25 bucks, and for the students, it's going to be 10 bucks. So write those down. Stay caught up with me here, please. And then I'm going to say that we had, let me think here. I'm going to try to figure out a total amount of money that will work nice. Give me just a second to do that. On that night, they raised $8,500. And remember, there's 3 times the adults. 3 times as many adults. There's way more adults. All right, can you write the 2 equations for that? All right, in a moment, one last thing. There's these real world constraints. They are equations that you have to include, otherwise you'll end up with the graph goes all over the place. And we want it contained to the first quadrant. So what are those real world constraints? Put those in there too. And then you'll have 4 equations from what I just told you. Just compare your equations to the kid next to you. I'll pause for a second while you converse. Okay, Josh, would you tell me one of your equations?
I haven't fully figured it out yet.
All right, I'm going to help you with one of them then. I mentioned that we had 3 times as many adults as students.
Y greater than or equal to X.
Okay, so we got, if I just say Y and X, and I set them equal for a second, we know they're not equal, but we want 3 times as many adults. So this one is way bigger. With that hint, where do I put the 3?
3 goes in front of the Y.
Very good. So there's a good equation. Now you might be thinking, shouldn't I do less than or equal to? I never said that. I said it was 3 times as many. I didn't say at least 3 times as many. I just said 3 times as many. All right. So there's X equals 3Y. Or you could reverse it and say 3Y equals X, but the 3 has to be on the smaller one. Okay. Next equation. Mr. Breen, can you tell me an equation you thought was right?
X is greater than or equal to 0.
That is a fact, Jack, and the Y greater than or equal to 0. Those are called the real world constraints. Good. All right. Let's see. Who else is... Car? You got an equation? How about the one that goes with the 8,500?
25x plus 10y equals 8,500.
Yes. Excellent. So now we got this equation that I mostly used white and green, and this equation, and these 2 equations. Now, I think you know that where the 2 lines cross is usually kind of a big deal, okay? Because if I graph these, one of them is just going to say stay on this side of the y-axis, one's going to stay on this side of the x-axis, and then one of them, this this one, after I divide both sides by 3, I have y equals x over 3, or 1/3 x. So it's going to be a line that goes kind of like that. And the other equation, this one, is, I'm not asking you to graph them right now, but they would go like that, and they would cross. My question is, do you remember how to use algebra? Not graphing, because you won't want to do that on the test. You'd want to use algebra to tell where this equation, x equals 3y, and this equation cross. Hint, I would use substitution. I would substitute one equation into the other. So I'm going to make it really clear. 25x plus 10y equals 8,500. And then x equals 3y. If you don't know how to substitute this and do substitution, you missed a big part of Algebra 2. You really got to know that. We had an actual paper worksheet on this. It had examples. But I know there's probably some of you, so let me help. X equals 3y. There's an x right there. You replace it with a 3y. So now instead of x right there, you're going to have 25 times 3y plus 10y equals 8,500. It's not the actual assessment day, it's me helping you day, so there, I helped you. Hopefully you knew that before me. How many of you knew how to substitute that already? Okay, good. So then you actually solve it. So you multiply it all out, add it up, divide it, do the math, and in the end, what's y equal to? What did you get, Sam?
180.
All right, so there's 100 y's, and back to our problem here, y was students, so there's 100 students. And then you can figure out how many adults there must be, because if this is 100, there's 3 times as many adults, so it must be 300. Yay, I solved it. All right, but really all I solved was that spot right there was 100 comma, is it 100? No, it's 300 comma 100, because the x was 300. Okay, awesome. That is typical linear programming. Now, this also could be a matrix. Do you remember how to write this as a matrix equation? Because see, matrices is the other thing we're reviewing today. Well, let's just stop for a minute and go back to more basic matrices. Would you just take this and put it in your calculator? 1, 2, 3, 4. That is a 2x2 matrix. See if you remember how to do that. In the calculator. Put that in the calculator. Under matrix. Go to matrix A, edit matrix A, and call it a 2x2 matrix. 1, 2, 3, 4. In a moment, I'm going to walk past, and what I want you to do is after you've entered that matrix A, I'm going to hit enter so that it shows up on your screen with the bracket, and it'll say 1, 2, 3, 4. That way I know you've got it in there. Because if you're hiding because you forgot how to do matrices and you just don't want to ask, I don't want to catch you. So I can help you. I can't help you if I don't know that you're struggling. Okay, you got this. There it is. Okay. Matrix A, there it is. Excellent. Thank you. Just like that. I'm gonna go down this road. You guys can hold it up so that it's easy for me to see. Yes, 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 yes. Yes, 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 yes. Okay. I'm gonna make the assumption that we've got everybody. Okay. So now, there were 2 things that we could do with matrices. And I want you to try to do it without the calculator first to see if you remember. Because remember, all we have to do is make that 2 into like an A, and then the calculator can't do it. So do you know how to do these by hand? The first one is called the determinant. Now I'll remind you where that determinant comes from. When you're doing the inverse, you want 1 over the determinant, and then you times by flip, flop these two, op those two. Now, one of the best things you could be doing for yourself right before the final is reviewing your little notes that you're making right now. These little practice problems you're doing. So maybe draw that little red diagram for yourself. That's for finding an inverse. You do 1 over the determinant, and then you flip-flop, yop-op. But if you can't do the determinant, then you can't do this process. But honestly, that's the hardest thing. It's just knowing what to do for the determinant. It's not really that hard. Isaac, do you remember what to do? What times what?
AC minus
Okay, but let's use the 1, 2, and the 3, and the 4.
1 times 4
Yep.
minus 2 times 3.
That's it. 1 times 4 minus the 2 times the 3. That's how you get the determinant. Good. Now finish it off, and your answer has lots of fractions in it. Get the inverse. Because the determinant's really easy. It's just a number that we just got right here. Now I think you'll see that you don't really need the calculator for a 2 by 2 matrix. You can do this. The determinant is -2. Do you guys agree? Okay. Then you have -1/2 in front of flip-flop the 1, 4, op the 2 and the 3. You got this. I'm going to pause for a second while you finish that off and then compare your answers. I'm not sure if they're all fractions, but if at least 3 out of the 4 of them are fractions. All right, I'm going to pause while you compare with the kid next to you. All right, so we figured out the determinant was -2. It was 4 minus the 6, -2. And now we flip-flop the 1 and the 4, so now the 4's here and the 1's here. And this is -2, and this is -3. And so now you just take that times that, so you end up with -2, +1, -3 divided by -2. Oops, so it's not going to be negative, is it? So it's 3 over 2, aka 1.5, also fine. And -1/2. There we go. Raise your hand if you had the same thing as me. Cool. You remember the main thing of little, like grunt work of matrices. Now, what do we actually use matrices for? Do you remember this problem we had a second ago? I'm going to show you this one and see if it reminds you. I can make a matrix equation out of this by going 25, 10, 0, 1. I want to make sure you really get where I got the 25 and the 10. And the 0 is because there was, oh wait, I'm wrong. There was 1 x, but there was 0 y's. I have that backwards. There was 1 x and 0 y's in this equation. See, I just had that backwards. And then this will be x, y, and then this will be 8,503. Now, the cool part is, if you make your A and your B matrix be these two, we see this is the A matrix and this is the B matrix. Let's take a second, type that into the calculator. And do you remember that deal where you do the inverse of A on both sides? Let the calculator do it, because at the end, just type those matrices in, matrix A and matrix B, get those typed in. Because at the end, you'll just be going inverse A times B. That's the key. Once you got your matrices in there. And I hope it comes out to the same exact thing we got last time. we already know the answer was 300 adults and 100 students. And if you don't get 300, 100, you probably did something wrong. I need a calculator for this, Josh. Type those two matrices in as a matrix A and matrix B. 25 tens, 1 0, that's A. Sir.
I didn't get, none of us are getting the right thing.
No, it's not right.
Okay, all right. Then something must be wrong. Let's try to figure out what's wrong. 25, 10, 8,500, okay. 1x, 0 y's. Pretty sure. Oh, I see what I did wrong. Okay, does anybody else know what I did wrong? Ooh, Isaac, what did I do wrong?
The Y to the other side.
Yes. This has y's. They're just over here. So I set up this bottom equation wrong. So it's not 1 and 0 and 3. So everybody go back and erase the 1 and the 0 and the 3. That equation from the lower level right here. Do you get, we need the y's to be in the front, so it should be, that 3y should go over here, and it'll be negative 3y. Negative 3. Now, but that's the y's. Wait a minute. The y's are over here. And the x's are in the front, so that's a 1. So 1, negative 3, these two right here have to be reversed because the x's have to be first and then the y's. And then this is still a y. And then when I moved this to the other side, I subtracted 3y from both sides. There was just nothing left over here. There's 0 over there. I bet you if you put that in now, that should work. Can anybody verify that came out to 200, or sorry, 300? Is it 300 to 100? Okay, good. All right. Well, I know we went kind of fast there, but I want to give you a lot of time to work. And I'd like to start the Schoology quiz for linear programming together. The first problem's pretty easy. Problem 3 is the only really hard linear programming question, and I would strongly recommend you do it because there's at least a couple questions like that on the final. So especially number 3 of your homework, you should look at that close. Then I'm also giving you a part of your homework today on matrices. Okay, so you really want to try to get to both of them today in class when you have all this time. But then when you get stuck, there's a kid next to you that you can ask for help. And because I'm giving you 2 assignments at once, I'm making them not due tomorrow because that's just not realistic, but it's due Monday. And you might be like, aren't we like taking the finals? Yes. So it's your job then. You don't have to get it done by tomorrow, Friday. You have to get it done by Monday. So over the weekend, you finish up your review for the final, which makes sense to me. And then what do we do tomorrow in class? Tomorrow in class, I'm going to give you an example of a practice final. And you're going to go through and go, I know that kind, I know that kind, I know that kind, ooh, I don't know that kind. And you're going to take some time to hopefully ask me more questions tomorrow about the big picture of the whole semester. You should be so well reviewed for this final that if you take advantage of today and tomorrow in class of asking me questions, you should be able to be rock solid, hopefully having remembered Algebra 2 really well, and that'll set you up well for pre-calc for next year. All right, so work hard for the next couple days, and then I think the final will go great. All right, that's all I got for the video for today.